time to finish off 4.2, which is on analyzing exponential functions. So just to remind you what an exponential function is, has the form f of x equals a times b to the x power, where a cannot equal 0, b is greater than 0, and b cannot equal 1. So just to remind you, last day what we focused on is when this a value here, when that a value was equal to 1. And today what we're going to do is we're going to take a look at when it's not equal to 1. So we're going to look at two cases. We're going to look at when the a value is greater than 0, and we're going to look at when the a value is less than 0. The only other case would be when a is equal to 0, but as we said, you are not allowed to have a equals 0. So this will cover all the cases, when a is greater than 0 and when a is less than 0. By the way, I've decided already that we're not going to do this. It's just too much. So we're going to do 3 on this side and probably 3 on the other side. So here we go. We're going to start by graphing y equals 2 to the x power. So what's the a value in this case? Is it 2? No, it's not. It's not 2 because b to the x, the base that's raised to a power is the b value. So this 2 is a b value. What does that mean the a value is? 1. Wait a minute, Mr. Welch, I thought you said we weren't doing that. We did that last day. Well, I just want to show you this for comparison's sake. So we did graph this last time when a equals 1, and I want to graph it again. So what I'll do is I'll make our old table. 3, 2, 1, 0, negative 1, negative 2, negative 3. Very fast. This is when y equals 2 to the x. So put 3 in there, 2 cubed is 8. Put 2 in there, 2 squared is 4. Put 1 in there, you get 2. Put 0 in there, you get 1. Put negative 1 in there. 2 to the negative 1, it's a flipping negative, you get 1/2. Put negative 2 in there, you get a quarter. Put negative 3 in there, you get an eighth. We can graph that. 3, 8 goes here. 2, 4 goes there. 1, 2 goes there. 0, 1 goes there. Negative 1/2. Negative 2 quarter, and then it gets closer and closer. And you remember this. This is an increasing function. It's getting bigger and bigger and bigger as it goes up here, and then it's getting closer and closer to the x-axis, which is the asymptote. Over there. This is what we did last time. So now what we're going to do, we're going to graph the same thing, but this time we're going to have an a value of 2. Still 2 to the x, but we have a 2 out front. Now be careful here. If I put 3 in here, it doesn't mean 2 times 2 is 4 to the third power. You have to do exponents before multiplying, right? So the first thing you should do is 2 cubed, which is 8, which is exactly what we did last time, right? There's our 8 right there, times 2 is 16. So all we're doing is taking that 8 really and multiplying by 2. Okay, if I put x is 2 right here, you'd have 2 squared, which is 4, like we had there, and then multiply by 2, you get 8. Oh, do you see what's happening? Everything's just being multiplied by 2. You're going to have all the same, like the first step's going to give you all these values, and then you just multiply by 2. So when I have this, if I put 1 in there, 2 to the first power is 2, yeah, and then multiply by 2 is 4. 2 to the 0 power is 1, times 2 is 2. 2 to the negative 1, you know, is a half, and 2 times a half is 1. Did that still work? Yes, negative 1's a half, and 2 times still works. If you put negative 2 in here, 2 to the negative 2 is a quarter, and 2 times a quarter is 2 quarters. 2 quarters is the same as a half. 2 to the negative 3. Remember, it's a flipping negative, so it becomes 1 over 2 to the third power, which is 1 to the 8th, and then when you multiply that by 2, you get 2/8, which is the same as a quarter. Okay, 3/16 doesn't fit. 2 and 8 fits, it's right there. 1 and 4, 0 and 2, negative 1 and 1, negative 2 and a half, negative 3 and a quarter, like this. So it's going to come down to the asymptote again, but it's a little bit above the red curve all the time. Ah, that's not very good, and I'm sure this will be terrible too, but anyway, like this. So I think the most important thing to notice is it's very similar shape, but all the y values are twice as much. That's what that 2 in front did here, is it took all the y values. This y value is 2, it's now twice as much, 4. This y value was 4, it's now twice as much, 8. So you can probably guess if we had done this one here, which I deleted, it's y equals 1/2 2 to the x. It's the same thing except it has a half in front of it. Can you guess what it would look like? We could actually draw this really, really fast on here. Why don't we do it? I'll do it in yellow so it doesn't take up a lot of space. It's 1/2 2 to the x. So you're getting these same values, this 8, this 4, this 2, but then you multiply them by a half. So it wouldn't be 3, 8, it would be 3, 4. It wouldn't be 2, 4, it would be 2, 2. It wouldn't be 1, 2, it would be 1, 1. It wouldn't be 0, 1, it would be 0 and a half. And then it would come down like this again, and it would go up here. By the way, maybe we want to figure out where the 4 would be. So let's put 4 in here. 2 to the 4th power is 16, and half of 16 is 8. So it would go through this point right here. Okay, so this one is actually right there. What a mess. I haven't done a very good job here. Here's something very important to look at. So in this one, the a value was a half. I can't even read that. In the last one, the a value was 2. And what I want to look at is the y-intercepts. The blue one, the y-intercept was 2, the a value was 2. The red one, the y-intercept was 1, the a value was 1. The yellow one, the y-intercept was a half, the a value is a half. Looks like a pretty good pattern. Remember, last time, every single time, the y-intercept, sorry, was 1, and that's because every single time last time, we had the a value of 1. Okay, one more. What's going to be different since our b value is a fraction between 0 and 1? What's going to be different is it's not going to be an increasing function, it's going to be a decreasing function. We did that last time. And as you can imagine, all the 3 is going to do is same thing, take all the y values and make them 3 times as big. Okay, here we go. So 1/2 cubed is 1/8 times 3 is 3/8. 1/2 squared is a quarter times 3 is 3/4. 1/2 to the first power is a half times 3 is 3/2. 1/2 to the 0 power is 1, right? Anything 0 power is 1 times 3 is 3. 1/2 to the negative 1 power, well, that's a flipping negative, so the 1/2 flips and becomes 2 times 3 is 6. 1/2 to the negative 2, so you flip and multiply and square it, so that's 4 times 3 is 12. And 1/2 to the negative 3, flip and cube it, that's 8 times 3 is 24. So 3 and 3/8, 3 and 3/8 is somewhere around there. 2 and 3/4, 1 and 3/2. 3/2 is the same as 1 1/2. 0 and 3, negative 1 and 6, negative 2 and 12, so it's somewhere up here. And we have our decreasing function, and it's really steep, it's going up really fast, and the reason for that, of course, is because we have an a value of 3. The bigger the a value, the steeper it's going to be, the faster it's going to go up, because you're multiplying those y values by bigger and bigger values. Okay, great. Let's go through the domain, range, blah, blah, blah. So the domain of all 4 of these graphs, what's the domain of every single one of them? All real numbers. Goes forever in the negative direction, always in the positive direction. You can say x is an element of all real numbers, or you can say negative infinity to infinity. The x-intercept, well, just like last day, there is no x-intercept. It never crosses the x-axis, so none. Similarly, what's the asymptote? Well, since it never crosses the x-axis, the asymptote must be the x-axis. Remember what the equation is of the x-axis? The equation is y equals 0. The range, so how high do all of these go? They go up forever. How low do they go? Right down to the x-axis, but they never reach it. So they go all the way down to 0, but they don't reach 0. The way you can say that is either y is greater than 0, or you can say from 0, but not inclusive, all the way up to infinity. The y-intercept. Now, interesting, before last day all we said was 1, but we can't say that this time. Notice, by the way, that the a value in this last example was 3, and the y-intercept is 3. So what can you say for the y-intercept in every single case? You can say that the y-intercept is equal to a. Whatever the a value is, that's what the y-intercept is. And the end behavior, remember that's the quadrants it ends at. And in these cases, they always end in quadrant 1 and quadrant 2. So we'll put 1 to 2, and I like to use Roman numerals when I do my quadrants. Alright, so that's when a is greater than 0. Now let's do when a is less than 0. So we'll start with y equals negative 2 to the x power. And I'm actually going to write the table way up here, which might make you nervous. It might think, what are you doing? You're going to cover up our space, but you'll soon see. Okay, so a couple things. First of all, what's the a value of this? Well, the b value is 2. Remember, we said that the b value has to be greater than 0. So the b value could not be negative 2 here. The b value has to be positive. The b value is 2. So what does that mean that the a value is? The a value is negative 1. Next thing, one of the most common mistakes people make here in all of high school math. If I put 3 in here, I have y equals negative 2 with the 3 there. And what a lot of people do is they say, oh, this is negative 2 times negative 2 times negative 2. No, you have to do the exponent before the multiplying. A negative sign like this means -1 times 2 effectively. So you have to do this first. The only way you would cube the whole thing is if the -2 was in brackets, but it's not in this case. So you do 2 cubed, which is 8, and then make it -8. You'd put in the next one 2 squared, 4, and then a negative. Next one, you put a 1 in here. 2 to the first power is 2, and then negative. Do you see this exactly the same as the very first graph we did, the y equals 2 to the x, except all the values are going to be negative, right? If you look back here, we had 8, 4, 2, 1, and now we're having -8, -4, -2, -1, and that makes sense because all we're doing is multiplying all those original values by -1. 2 to the 0 power is 1, -1. Oh, this looks complicated. You have y equals -2 to the -1. That's okay. First of all, you do the flipping negative, and then you keep that negative up front, so it's -1/2. If you had -2 here, it'd be flipping negative, then you'd square it, so you get 1/4, then multiply by negative, so you get -1/4, and the last one's -1/8. Okay, 3 and -8 is down here. 2 and -4, 1 and -2, 0 and -1, -1 and -1/2, -2 and -1/4, and -3 and -8. So you can see that this is a decreasing function. You can see that it has the same asymptote. It's getting closer and closer to the x-axis. Big difference though, it's down in the third and fourth quadrant. Where's the y-intercept? It's at -1. What was the a value of this? -1. So it still works. It's still going to be the a value. So when the a value is negative, what it does is it flips the thing over so it's now in the third and fourth quadrant instead of the first and second quadrant. Basically, by having a negative a value, you're causing it to there to be a reflection over the x-axis. Okay, so the next one, the a value is equal to -2. First of all, we put 3 in here. 2 cubed is 8 times -2 is -16. You put 2 in here, 2 squared is 4, times -2 is -8. Put 1 in here, 2 to the first power is 2, times -2 is -4. So compare these to these. What's the only difference? You're multiplying them all by 2 again. And that makes sense because it's exactly the same, except instead of having a -1, you have a -2. So instead of having -1 here, you should have -2. Instead of -1/2 here, you should have -1. Yeah, all the y values should be twice as much. This y value was at -2, right? 1, -2. Now it's going to go down to -4. This y value is at -4. It should go down to -8. This y value is at -8. It should go all the way down to -16. That doesn't fit. This was at -1/2. It should go to -1. This was at -1/4. It should go to 1/2, etc., etc. Oh, at 0, it should be at -2. Yeah, 2 times -1 is -2, so it should go there. I hope that didn't confuse you the way I did that. So it should go like this, and then get closer and closer and closer, like this. A value, it was -2. Y-intercept is also at -2. We can do this next one again really fast. It's exactly the same, except instead of multiplying by -2, you're multiplying by -1/2. Remember how we took all these y values and multiplied them by 2 to get the new y values for the green one? Well, now what you'd be doing is taking all those y values and multiplying them by 1/2 to get the y values of this yellow one here. So let's do that extremely quickly. In the red one, the y-intercept was at -1. Now it should be at -1/2, and that totally makes sense because our a value is -1/2. In the red one, this was at -2. Now we'll go to -1. This was at -4. We'll go to -2. This was at -8. Would go to -4. The next red one down would be at -16. That would go to -8. This one was at -1/2, so it'd go to 1/4, and we can't really squish anymore in there. So I hope you're seeing that this is very similar to what we did on the other side of the page, except it's all reflected over the x-axis. Look at those 3 right there. Compare them to these 3 right there. I've kind of messed the colors up, unfortunately. I should have been consistent with my colors, but I think you'll get the sense how they're just reflected over the x-axis. So the last one we have to do is this one here. So we'll actually do this. 1/2 cubed is 1/8 times -3 is -3/8. That's a 3. 2. 1/2 squared is 1/4 times -3 is -3/4. 1/2 to the first power is 1/2 times -3 is -3/2. 1/2 to the 0 power is 1 times -3 is -3. 1/2 to the -1 is 2 times -3 is -6. 1/2 to the -2 is 4, because you flip it and then square it, you get 4 times -3 is -12. And 1/2 to the -3, flip it, you get 2. Then cube it, you get 8, and then multiply by -3, you get -24. Well, that's not fitting on our graph, is it? So we get 3 and -3/8, so somewhere around here. You get 2 and -3/4. You get 1 and -3/2, which is -1.5. 0 and -3, -1 and -6, -2 and -12, which is somewhere down here. And we have our answer. So this time we have an increasing function. All these ones were decreasing. This one's increasing. Asymptote's the same place. Y-intercept is at -3, and sure enough, our A value was at -3. So let's summarize these and see if there's any differences from what we did on the other side. Domain, any differences? We said on the other side it was all real numbers. Absolutely, still all real numbers. So you can say x is an element of all real numbers, or from -infinity to infinity. X-intercept, any difference? On the other side we said none. I would still say none. There's no x-intercept. Asymptote, what's the asymptote? It's still the x-axis. In other words, it's still y equals 0. So far nothing's different. Let's go to y-intercept. Why am I doing that one? Because that one also doesn't change. The y-intercept in this one's -3, -3, -1/2, -1/2, -2, -2, -1, -1. So the y-intercept is still A. But these ones here are not the same as the other side. Let's go back and look at the range and end behavior of these ones. So the range we said was y is greater than 0. The y values went from 0, not inclusive, all the way up to infinity. Is that true here? No way. These ones go up to 0, but they go down to -infinity. So our range is all the y's are less than 0, or from -infinity up to 0. So that's different. Let's go back and look at end behavior. End behavior here we said was from quadrant 1 to quadrant 2. These all start in 1 and end in 2, or start in 2 and end in 1. Is that the same here? Again, no way. These all start in 3 and end in 4, or start in 4 and end in 3. So our end behavior is 3 to 4. So range and end behavior depends on the A value. But the other 4 things we have listed here are always the same. Doesn't matter what the A value is. Okay, sorry about another long video. That was a real slog to get through all this.